Hello everyone, this is Divya, Assistant Professor, Department of Computer Science with Data Analytics, Dr. SNS College of Arts and Science. So in today's Big Data technology, we are going to see about clustering in Big Data. So I just start with the introduction here. Clustering in Big Data is discovering the hidden patterns and structure in massive data set through the intelligent grouping and analysis. So here, what is the cluster in big data? Normally clustering is unsupervised machine learning technique which is automatically groups the similar of the data points which is into the meaningful cluster, right, without any requiring the predefined labels or categories. This powerful approach normally giving you the natural patterns, trends and structure hidden within the massive data set, which is making it essential for the modern data analysis, where the pattern discovery which is uncovers the hidden relationship in a complex data, and which is data summarization which is reduce the complexity while preserving the key insights, and anomaly detection that is identified outliers and unusual patterns here. So why clustering matters in big data? For the first, unpredicted scale, that is which is modern organization process which is having the data from the different resource, which is including maybe a social media or blogs or sensor web blogs or any transaction systems. So when we go with the traditional limitation, which is the making clustering algorithm cannot be handled the volume and the velocity of the three V's. So the characteristic of the big data environment. So when we making the real-time intelligence, that is scalable clustering algorithm enables the organization to extract the insights and making the informed decision in a real time. So key challenges in your big data clustering, where the computational complexity, first one, that is algorithms like k-means or NP-hard, which is making them very computationally instance of the for the massive data sets. So next, memory constraint. Of course, yes, the traditional system which is struggle to hold the entire data sets for the memory processing. Dynamic data stream handling the continuous evolving of the data and also maintaining the cluster relevance over the time. The quality and scale trade-off, obviously the maintaining the clustering accuracy which is achieving necessity for the scalability here. Common clustering algorithm for the big data. K-means variance, that is approach iterative or centroid based partitioning, where the scalability which is enhance the map reduce implementation like the K-means. For the best, we just making the clusters with a similar size here. So density based methods for like algorithms like DB-scan and DB-DC, which is the strength discovers the cluster of shapes and handles the noise effectively. Best for the non-clusters which is having the various density here. Hierarchical approaches, obviously we know that which can cure with this method construct the cluster tree efficiently for the large data set, and which is best for the nested structures. Randomized method of your projections and sampling, with the advantages is which is reduced dimensionality to accessing the accelerator for the clustering here for the best for the high dimension data spaces here. So clustering process flow chart here, which is iterative and convert for the assign and update and check. Initialization, which is select with the initial parameters here, and pre-processing with a clean or normalization, and data collection which is gather the raw data here. So clustering types for the visualized algorithm choice depends on the data distribution, that is it may be different clustering algorithm or identifying the different cluster shapes and structure, which is understanding the patterns and crucial for the selecting the most appropriate techniques here. So whether scalability techniques in big data clustering, we just go through it. One pass algorithm, parallel computing, dimensionality reduction and stream clustering. Well here one pass algorithm which is search for the bridge achieves in the memory efficiency through the tree construction, where the map reduce framework which is Hadoop Spark, which is distribute the clustering tasks across the multiple nodes. Random projections and strategic sampling the reduced data size, which is preserving the structure here. Finally, where the cluster in real time as a new data arrives continuously here. So practical application of big data clustering where the customer segmentation, social network analysis, fraud detection and healthcare analysis. So whether here the some of the application of big data clustering with the customer segmentation like Amazon or Netflix, which is clustering the group of the customer by the behavior and enabling the personality recommendation for target marketing companies, where the social network analysis which is directing their communities and influence patterns across the billions of nodes for like Facebook and Twitter. Fraud detection, financial institution identity, that is anomalous transaction cluster. It may be for the normal patterns on which is prevent from the fraudulent activities. So healthcare analytics is grouping the patient data enables which is personalized treatment plans and identification for the high risk population here. So finally we go with the mind map clustering big data technology where the algorithm k-means and bridge DB scan. And challenges, it may be a scalability and memory and quality, where the pre-processing, initialization and iteration is the main process here for the data collection techniques. For the application, yes, we just make a marketing or for deduction and healthcare and social also we concentration the application on. So we just go through with the clustering process in big data technology, the way we just make an overview here. So for the next class we just make a discussion in detail. Thank you so much.